Have you ever pondered the paradox of the sun? It's the most visible object in our sky, yet its inner workings remain a mystery. The sun, the magnificent heart of our solar system, is an enigma with an aura of brilliance. It's a colossal celestial body, about 109 times the diameter of Earth. It's a staggering 93 million miles away from us, yet we feel its presence every day. The sun is not merely a glowing ball of light, but a star, a colossal sphere of hot, glowing gases. It's predominantly composed of hydrogen and helium, with traces of other elements like oxygen, carbon, neon, and iron. It's the radiant energy from these red-hot gases that lights up our days and warms our world. But there's more to the sun than meets the eye. Within its core, a powerful process takes place. It's here that the sun's true magic comes to life: nuclear fusion. This process is a crucible where hydrogen atoms combine to form helium. It's a dance of subatomic particles that happens at temperatures of around 15 million degrees Celsius. This extraordinary process doesn't just create helium, it releases an enormous amount of energy, so massive that it powers the sun and sends waves of heat and light hurtling through space. This energy travels 93 million miles, crossing the cold void of space to reach us here on Earth. This energy is life-sustaining. It powers photosynthesis in plants, drives the weather systems, and influences the Earth's climate. It's the energy that makes life on Earth possible. So the next time you feel the warmth of the sun on your skin, remember, it's not just a bright spot in the sky, it's a complex, mysterious star, a giant nuclear reactor that powers life on Earth. It's a cosmic powerhouse, a mystery in plain sight, silently spinning in the vast expanse of space. So, the sun is not just a bright spot in the sky, it's a giant nuclear reactor powering life on Earth. Ever wondered about the impact of this giant fiery ball on our planet? Let's start with the basics. The sun's energy drives our weather patterns and ocean currents. It's a huge engine of heat and light that powers Earth's atmospheric dynamics. When the sunlight heats the Earth's surface, it causes the air to rise and create low-pressure areas, leading to winds and storms. The same energy also drives the ocean currents, helping to distribute heat around the planet and regulate our climate. But the sun's influence doesn't stop there. This celestial powerhouse is also the primary source of energy for photosynthesis in plants. This process not only allows plants to grow and thrive, but it also produces oxygen, an essential element for most life forms on Earth. So, in a way, the sun is the silent partner in every breath we take. Now let's talk about seasons. Ever noticed how the length of our days changes throughout the year? That's the sun's doing too. The Earth's tilt in relation to its orbit around the sun determines the intensity and duration of sunlight received by different regions at different times of the year, creating our familiar cycle of seasons. However, it's not all sunshine and rainbows. The sun also has a darker side. It emits ultraviolet radiation, a type of light that's invisible to the human eye. While a little bit of UV radiation helps our bodies make vitamin D, too much of it can cause skin damage and even lead to skin cancer. It's a powerful reminder that even the most life-giving forces can also pose challenges, so there you have it. The sun's impact on Earth is multifaceted and profound. From driving our weather and ocean currents to providing the energy for photosynthesis, from shaping our seasons to emitting harmful ultraviolet radiation, the sun plays a crucial role in virtually every aspect of life on our planet. From shaping our climate to fueling life, the sun's influence on Earth is immense and undeniable. How long will the sun keep shining? What's the life cycle of this cosmic powerhouse? Let's take a cosmic trip and explore this celestial journey. It all starts in a nebula, a massive cloud of gas and dust. Over millions of years, gravity pulls this material together to form a protostar. Our sun, a star like any other, was born this way. As the protostar matures, it becomes a main sequence star, burning hydrogen into helium in its core. This phase is the longest in a star's life, and it's where our sun currently resides in its middle age. Fear not, our sun still has about 5 billion years of hydrogen fuel left before it starts to change. In its twilight years, the sun will swell into a red giant, eventually casting off its outer layers and leaving behind a white dwarf. But don't worry, that's billions of years away. The sun's life cycle is a cosmic journey of epic proportions, a testament to the grandeur of the universe. So what have we learned about our closest star? Let's recap. We've explored the sun's composition, a fiery fusion of hydrogen and helium, generating immense energy through nuclear fusion. This process, as we've discovered, releases light and heat, making life on Earth possible. Next, we delved into the sun's profound impact on Earth. From driving our climate and weather patterns to triggering auroras and influencing our technology, the sun's influence is far-reaching and integral to our existence. We also took a journey through the sun's life cycle. From its birth in a stellar nursery to its future demise as a white dwarf, we've seen that our sun, like all stars, has a finite lifespan. In conclusion, we've unraveled some of the mysteries of our everyday companion, the sun. Yet it remains a complex and fascinating cosmic entity, an enigma that scientists continue to study and understand. The sun, our everyday companion, is a complex and fascinating cosmic entity, an enigma that scientists continue to study and understand.